In this video, we'll be looking at the composition of two functions. We have f of x equals the square root of 9 minus x squared and g of x equals the square root of x minus 1. The composition is written like this. F composed as g of x. That's not fog, that's just the math notation. What that means is f of g of x. I like it written like this because then it shows that what we're doing is plugging in this function g of x wherever we see x in the f function. So let's rewrite that one more time. That's f of whatever g of x is. So that's the square root of x minus 1. So I'll plug that in there. Now let's continue plugging that in. So f of the square root of x minus 1. I'll switch to black now because we've got this function here, and that is the square root of 9 minus something squared. That's our something is our x, our variable there. So what I'm going to plug in is the square root of x minus 1 right there. Now that is correct. If you were to just plug in a value for x, you could get the output correctly. But let's clean it up. Let's simplify that a little bit. So we get that to be equal the square root of 9 minus, well, the square root of something squared is just that something, but this is going to stay in parentheses. Be careful here. So this negative sign then gets distributed, so we get the square root of 9 plus 1, so that's 10, and then minus x. Okay, so that is f composed as g of x. At this point, you probably have this burning question. Well, what is the domain? I'm sure you probably do have that question. What is the domain of this composed function? Well, first of all, let's look at this. The domain is constrained by, of course, this part, the f of g of x. It's also constrained by g of x. So let's first start on this f of g of x. The domain will be like this. We cannot let the radicand, what is under the radical sign, to be negative. So we cannot let 10 minus x be less than 0. So it has to be greater than or equal to 0. So that's what I'm doing there. I'm just setting up an inequality because 10 minus x must be at least 0. It can be 0, but it has to be at least 0 or greater. So then we get negative x is greater than or equal to negative 10, which means x is less than or equal to positive 10. Okay, we've got that constraint, but we also have this other constraint from g of x, and that is that x minus 1 must also be greater than or equal to 0. So solving that, we get x is greater than or equal to negative 1. So now what we have are these two constraints. So x will be somewhere between negative 1 and 10. So that's how we find the domain of this composition of functions. I hope that helps.